skip steps?
Oh yeah, major.
But then sometimes I feel like you get flustered if I skip. And I don't know when I should or when I should.
Flustered all the time.
Oh, okay. Well, if you get flustered, tell me to stop or slow down.
I'm flustered.
Okay, just leave the room. Did you say I'm buster? I'm
Flustered.
Just so she knows.
So flustered. You can't even say it.
Okay. Okay, so I'm going to isolate for EK max because I'm trying to find speed. So I should think, okay, that's about kinetic energy. Okay, too many explanations. Okay, I get it.
So how come there's that one formula that's like EK max equals QEV stop? Have you ever used that?
Yeah.
Yeah, if it's asking for stopping voltage.
Is EIN only, is that only work for FE or HF equals HC over lambda? Or does it work for other ones too?
Like work, you couldn't use HC over lambda.
Okay.
Okay. So I'm just solving for EK max first to make it simpler, and then I'll do the speed calculation after. Oops. I didn't leave enough space. So I get an EK max of 0.248 electron volts. Now, here's the thing. When you use, so like the next thing I should think is I'm going to use EK equals half mv squared, not squared, okay? When you're using this formula, you can only use joules. Okay, because the units for joules and meters per second won't work if you use EV.
So really you have to do this in 2 steps, this question. You can't just rearrange it.
That's right, you can't rearrange the formula. You got to solve for EK and then convert it to joules.
So is EK just 1/2 mv squared and delta EK 1/2 mv squared minus 1/2 mv squared? Or is it,
Can you say that again? Is delta?
is EK just 1/2 mv squared and delta EK is 1/2 mv squared minus 1/2 mv squared?
I am saying like EK max, so it's like almost like EK final. So that can be just straight half mv squared. I guess if you were asked what is the change in energy, I don't know if you would be.
You know, let's just have just the one.
Yeah, generally, like for that assumption where we use the conservation of energy, you're using EK max, so or think about it like as almost like as EK final in a way. But we just kind of say EK max because we assume that it's not accelerating. It would get more complicated.
Can you just do it in one step if you use the H with joules and then convert your work to joules before you put it in?
Perhaps, yes. If your units stay good, yeah. Okay, so convert this to joules with the step I'm doing here. You got an answer?
Yeah.
Good. And think about it too, like you're dealing, what has speed? What has energy at this part of our equation and assumption? Electrons, yeah, so your mass is your electrons, right? You use your mass of your electrons. So your final speed 2.95 times 10 to the 5 meters per second. Did you get that?
Yeah.
Right on.
What'd you set for your M?